X-ray satellite peaks or the additional peaks appear in XPS spectra. So in this video, I'm going to explain that what are satellite peaks, why they appear in XPS spectra, and how to remove these additional satellite peaks. As we know that in every standard XPS spectra, there are photoelectron peaks, there are OJ peaks. These two peaks are very common. But there are also additional peaks such as X-ray satellites peaks, X-ray ghost peaks, Kα peaks. Look, this is the standard XPS spectrum for silver. And we can see that there are photoelectron peaks, these are basically photoelectron peaks, and there is also OJ peaks. But there are also additional peaks, this one here and this one, these are basically called satellite peaks in X-ray satellite peaks, because there are also other type of satellite peaks such as shake-up and shake-up, but these peaks are basically called X-ray satellite peaks. These peaks are appearing in XPS spectra because of one reason. So the one line answer is these peaks appear in XPS spectra because we use non-monochromatic X-ray sources. Non-monochromatic means the X-ray source is having multiple X-ray energies, because we know that the X-ray produced in the anode, we use two type of material. One is the aluminum, another is magnesium. So these sources not only produce the characteristics X-ray, which is the Kα 1 and 2 line, but they also produce some other type of radiation, that is brainstorming radiations at higher energy. These other types of radiations are at higher energies, so these satellites peak will appear at lower binding energy. As we explained that these additional satellites peaks appears when we use multiple X-ray energies. So we know that when we use the Kα 1,2 line, so we get the photoelectron peaks, right? But when we use some other type of radiation such as Kα from 3 to 6 and Kβ, so we get basically these additional satellite peaks. Look at here, as I explained that in XPS we use two common X-ray sources. One is magnesium, this is the energy range here, and one is aluminum, this is the energy range here. So we use non-monochromatic. Non-monochromatic mean multiple or many energies, multiple energies, right? Magnesium X-ray source, and when we bombard magnesium X-ray on the samples, so we have the most intense peak here. These are very high intense peaks, and because of these peaks we get photoelectrons. But there are also less intense peaks such as MgK alpha 3, and because of this we get satellite peaks, right? Similarly, let's see here that aluminum. For aluminum we have these two intense lines here, but there are addition to this Kα 1, Alpha 2 line and aluminum source, and these are weaker lines, the Kα 3 to Kα 6. And there is also another peak, another line, that is Kβ, and because of these additional lines, these additional X-ray energies, we get satellite peaks. So now, how to avoid these satellite peaks in XPS spectra? So the answer is very simple. We have to use monochromatic X-ray source. We have to use filter in order to filter these lines. So we will have only these Kα lines in our hands, and we will only get the photoelectrons and OJ peaks, and we will not get the X-ray satellite peaks.